Okay, so in this video, I'm going to review a bit of how to find angles and some review of trigonometry for different kinds of triangles. So the first thing I want to remind you of is that if I have a right triangle, like this, and if this angle is theta, then my second angle here is 90 degrees minus theta. And if you don't remember where that comes from, you can remember that the fact that the sum of all the angles in the triangle is equal to 180 degrees. So if I have 90 degrees plus theta plus, I'll call this one theta 2. Theta 2 is equal to 180 degrees. Then theta 2 is 90 degrees minus theta. So for example, if I have a triangle here where this is a 30-degree angle, and this is a right angle, now this angle here will be 60 degrees. Okay? Now, what about if I have a right angle like this? This is a right angle. And then my theta 1 here. What's theta 2? This theta 2 is also 90 degrees minus theta 1. And that comes from the fact that theta 1 plus theta 2 is 90 degrees for a right triangle. So then when I solve this equation for theta 2, I get that theta 2 is 90 degrees minus theta. So how can we apply this? Let's go back a few topics ago to thinking about an inclined plane. So I have an inclined plane here. And say that I give you this angle theta. And we'll say here that theta is 20 degrees. And then if I have a mass on this plane, and my force of gravity exerted on that mass is pointed straight down. Now in this kind of situation, we're going to usually define our coordinate systems like this. So our x and y is along the plane. And then I want to write FG as a vector, where I've got an fx and an fy. And I know that the magnitude of that force should be mg, which is fx squared plus fy squared. But from this geometry here, how do I find that force? Well, let's look at the triangles we've got here. So I'm going to just draw the vector now. So I've got the force of gravity that's going straight up and down. If I draw just the triangle that I had before, I've got this triangle like this. It's my inclined plane. This was 20 degrees. This was the top of my plane. Now, I want to remind you about similar triangles. So the plane triangle is this one. By the principle that we just said in our previous, at the beginning of this video, we know that all the angles in the triangle need to add to 90. So this is a 70-degree angle up here. Now, the triangle that my force of gravity makes, I can draw that here. We can call that a similar triangle. And if you remember from your geometry, similar triangles have the same angles. So that means that if this angle here is 70 degrees, this angle here is also 70 degrees. So now let's draw just that part. So I've got my force of gravity. I've got the angle of the inclined plane. This is 70 degrees. And now remember, this is now my x-axis. And this is now my y-axis. I'm going to redraw those in a different color. So my axes, I'm going to redraw over those in purple. So I've got purple x-axis, purple y-axis. My gravity is in green here. And I want to write the force of gravity in terms of those two components. Now, I could also draw this rotated. So if it helps you to draw this up and down to see the next part, remember, you could rotate this and draw it like this. You can also imagine turning your head sideways to get between those. Okay. Well, let's go back up. Let's look at this way of looking at it here again. And let's write our force of gravity in terms of each of these components, okay? So now if I want to write f of g in terms of my x and y, if I'm using my 70 degrees, then my x is the cosine because it's the adjacent side of that angle. So I've got fg cos 70 degrees, and it's going to be positive because I'm going in the same direction as my positive x-axis. And then for y, that one's going to be sine 70 degrees because it's over here, right? This is the y component. I'll also I'm going to write the x and y components of this gravitational force in orange so you can see them on top too. So I've got f y g f x g. So my f y g is fg sine 70 degrees. And now let's get the sign of that. That's negative because my y-axis is negative. Okay, so that's how I write that one as a vector. Okay. Now let's apply these same geometric principles to thinking about the angles that we need to use in a torque problem. So now I'm going to draw an example torque problem. So I've got the top of a bolt here. And I've got a wrench. Let's say my wrench is 30 centimeters long. And I say I apply a force at a 30-degree angle. Okay? Now, I want to find the torque. So my torque is R times the perpendicular component of my force. That's the perpendicular to the R component of my force. So if I've got my R vector, I'll draw that in another color. We'll do that in orange. So my R is here. I want the component of force that's perpendicular to R. So let's do that in purple here. So this is my F perpendicular. Okay. I can also write that as F sine theta. So to see that, let's draw this again in a different way. So I've got my F here. I've got my 30-degree angle here. I'm going to draw my F perpendicular on this side. And now hopefully you can see that because this is the opposite of this theta, that's why I have a sine theta here. Okay? And then one more thing that I forgot to say about inclined planes is that I just showed you, if I go back to that inclined plane example, I said this was 20 degrees, this was my force of gravity, this was 70 degrees. You may be used to thinking of, so I wrote FG is mg cosine 70 degrees negative mg sine 70 degrees. We also could have written that as mg sine 20 degrees negative mg cos 20 degrees. Let's draw how we can get that. So if we had drawn our x and y axis like this, this is my force of gravity again. This angle was 70 degrees. That means that this angle here is 20 degrees. If I use this 20-degree angle, now this is my Fy component. This is my Fx component. This Fy is adjacent to this angle, so that's a cosine. And my Fx is opposite of this angle, so that's a sine. So it just depends which angles you use. So this, here I'll do an orange box around those. If I use that angle to find my components, then I'll use sines and cosines the way it's written in orange. If I use these, those are the same vectors, but now I've used this angle to calculate them. And I get that. So it's the same answer, just two different ways to do the math.